Wagwan everybody, and welcome back to Jumanji. Today we're going to talk about ionic versus covalent compounds, right? And in simpler terms, for a compound to be ionic, it has to be bond formed between two or more metal and non-metals, right? Versus covalent, where the elements combined need to be non-metals, right? Now, in deeper terms, the electronegativity value of each atom involved in the compound is what really helps determine whether or not the compound will behave as ionic or covalent, right? So each atom on the periodic table is assigned an electronegativity value. Fluorine is our most electronegative, has a 4.0, and francium is the least, right? Hydrogen has no fixed position. It can behave as an alkali metal in group 1, but it can also have an electronegative value of a 2.1, putting it right by phosphorus, right? And if you check out my previous video, remember that electronegative value increases as you go up and right across the periodic table, right? There's a little mnemonics there for you to remember it. So anyways, when you combine the elements in a compound, right, if the difference in their electronegative value is 2 point more or greater, then we have an ionic compound, right? For example, fluorine 4.0, lithium is a 1.0 with a difference of a 3.0, right? Ionic. When we take covalent bonds, right, they can further be broken down into those that are purely covalent and those that are polar covalent, right? For a bond to be purely covalent, that electronegativity difference in the values need to be 0. Chlorine and chlorine cancel out each other, right? 0. Hydrogen, hydrogen as well, right? Now, for a bond to be polar covalent, the electronegative value need to be between 0 and a 2.0. For example, carbon and oxygen, 3.5, 2.5, right? A 1.0 difference. Now, for ionic compounds, right, one element is so much more electronegative than the other, pulling all the electrons onto itself, right? So one compound, fluorine here, is holding all the electrons. There is no sharing of electrons in an ionic compound, right? In a polar covalent, we have a sharing, an uneven sharing of compounds. We have one more, one less, but not to the extreme as the ionic, right? Now,